morning, viewers. This is Kasturi Day. Today I'm back with some leftover question answers, ICSE specimen question answers of this chapter that is motion in one dimension chapter. And somebody has requested me to discuss last year's questions. I will do so. So before, let us finish these, and then I will these chapters first, and then I will discuss the question answers of the last year's. Okay, so before I start, I will request you to please to subscribe my channel and ring the notification bell, because it will get you the notification as soon as new video is uploaded. And if you're liking the video, press the like button, share with your friends so that they can also be benefited from these videos. Okay, and please do meditate before starting your day or your studies. Okay, so this will help you in concentration, increasing your concentration, increasing your interest in the studies, and also get good marks. So let us meditate for 1 minute and then start with the discussion for today. Okay, so for meditation, think of a point of light. You can think of bulb also, doing bulb as a point of light, and concentrate on that. Think that the light is coming on you, bringing you energy, giving you energy to your whole body. Each and every part of your body is getting energy. Okay. And each and every part is enjoying to get that energy and getting interest in whatever you are doing. And that's why you're becoming successful. You're getting good marks. Think positive and think positive. It will help you get good marks, what you want. Okay. So let us enter our day meditation, and then we start with the discussion. So first question today we will discuss the table below shows, question number 7 it is, the below shows the distance in centimeter traveled by objects A, B, and C during each second. Select the object which is moving with constant speed. Give reasons for your choice. Select the object which is moving at a constant acceleration. What is the value of this acceleration? Select the object which is moving with variable acceleration and find how much distance each of the objects A, B, and C cover in 5 seconds. So this is the table. See, for first second, object A moves 20 centimeter, object B 20 centimeter, object C is 20 centimeter for second. Object A again 20 centimeters, B 36, C 60 centimeters. Then third second, object A moves to 20 centimeter again, B moves 24, C moves 100 centimeters. Then fourth second, object A moves 20, B moves 30, C moves 140. Then fifth second, A moves 20, B moves 48, and C moves 180. Okay, so from from the questions, first question is select the object which is moving at constant speed. Give reason for your choice. So first question, this is the 7th one. Object A is moving with constant speed because it is covering equal distances in each second throughout. See, from the chart we can see, so object A in every second it is moving, it is maintaining its speed, that is 20 centimeters moving. So this is at constant speed. B is variable because sometimes it's increasing, sometimes it's decreasing, and C is constantly increasing. Okay. So object A is the answer for the first one. Okay. Now second is which has constant acceleration. Question. Select the object which is moving with a constant acceleration. Okay, what is its value of this acceleration? What is the value of the acceleration? So for this, let us move on to the answer. It says that object C is moving with constant acceleration because its speed is constantly increasing at each second. After every second, the speed is increasing. We have seen that total speed is increasing. Okay, so constant rate is there, increasing rate is there in each second. So that's why it has a constant acceleration. Now the value of this acceleration is 40 centimeters square, 40 centimeter per second square. Okay. Okay. Now question, that is number C for seventh part. Seventh main, third question. That is, select the object which is moving with variable acceleration. That is the second one, object B. It is because we have seen that from the figure, from the chart, the body is constantly changing its speed. Okay, it's very irregular. Sometimes it's increasing, sometimes it's decreasing. So it's constantly changing. That's why it is variable acceleration. Okay. Now, for the fourth one, find how much distance each of the objects A, B, and C cover in 5 seconds. This, total distance covered by B in 5 seconds. Okay. So first is A in 5 seconds is 5 into 20 because it has constant acceleration. So 5 into 20, that is 100 centimeters. Okay. Then total distance covered by B in 5 seconds. That is, first we need to add all the distances. Okay, so first is 20, 36. In every second it's changing, no? So 20, 36, 24, 30, and then 48. That means 158 is the total distance. And that is multiplied by 5 seconds. Okay, so we will see that 158 centimeters this is 158 centimeters. Okay, so first that is 158 centimeters it is covered, and in the first one A it has covered 5. There were 5 centimeter, 5 distances were there, that is 20. Then if you add all the distances, that means 20 plus 20 plus 20, that is 5 times. So 5 20s if you add, that becomes 100 centimeter for the first one, for by A, covered by A. Total distance covered by A. Total distance covered by B is add all the distances which has been covered in every second, and then that will give you 158 centimeters. And for C, again we need to add all the distances which is covered by C in 5 seconds. So that will give us 500 centimeters. Okay. Now let's move on to question number 8. A lift gets accelerated from a rest to speed of 72 kilometers per hour in 1/12 minutes. 1/12 minutes. Okay. If then it then moves uniformly for next 30 seconds before coming to rest at the topmost story of the building in 8 seconds. So it gets accelerated to a speed of 72 kilometers per hour. And then that means speed is 72 kilometers per hour, and then it covers in 1/12 minutes, and then it uniformly moves in for next 30 seconds to rest, stops there at the topmost story of the building in 8 seconds. Now draw a velocity time graph of the lift. What is the acceleration of the lift? What is the retardation of the lift? What is the height of the building? Okay, this is part A of 8, question number 8, 8A. Okay, This. Okay. So this is a velocity time graph we have made. See, for it starts from 0 and it gains a speed of uh, 72 kilometers per hour, or you can say it converted to meter per second. Okay, so it will be around 20 meter per second. So that will move on to velocity of 20 meter per second, and then it moves at the same speed for 5 seconds. Sorry. This takes 1/12 of a 1/12 of a minute. That is 1/12 into 60. Okay, that means 5. For 5 seconds, it moves like this, and then it moves at the same speed. Okay, for 30 seconds. For 30 seconds, it moves at the same speed, and then it comes to rest. Uh, comes to rest at the topmost story building in 8 seconds. Okay, so see, for 30 seconds, from 5 to 35, that is 30 seconds, it moves in the same speed, and then after that, after 8 seconds, it comes to rest. Okay, and slows down and comes to rest. That is, its velocity decreases to 0 meter per second. Okay, so this will be the graph. It will be a trapezium starting from origin, that is 0. Then for 5 seconds, it will move with the velocity, or it will increase its velocity to 20 meter per second. Then it will move in a straight line, that is 20 meter per second. Continuously, it will move for 30 seconds, and then after 30 seconds, it will slow down and it will come to rest after 8 seconds. Okay, so this will be the graph. Now, 1/12 of the what will be the height of the the acceleration of the lift? What will be the acceleration of the lift? That means 1/12 of a minute. That is 5 seconds. So acceleration of the lift will be velocity by time. Okay, so 20 minus 0, final velocity minus initial velocity by time, that is 5 seconds. For the first 5 seconds. So for the first 5 seconds, what will be the acceleration? That will be 4 meter per second square, because initial velocity was 0 and final velocity is 20 meter per second. So 20 minus 0, that means 20, divided by 5 minus 0, that is 5. Okay, that will give us 4 meter per second square. Now, retardation of the lift, after 8 seconds, it will come down. It will come to rest. So final velocity becomes 0, and the initial velocity was 20 meter per second. So 0 minus 20 and 43, that is 8 seconds. No, so the 43 minus 35, that is 8 seconds. Okay, so that means minus 20 by 8 it becomes. So that will give us minus 2.5 meter per second square. That will be the retardation of the lift. Now, height of the building, it says in the question that it will stop at the 8th floor. So what will be the height of the building? Say area of OAE plus ABDE plus BDC. Triangle OAE. You think of the figure in the graph. In the graph, see the figure. See, we need to find out the area of this, which will give us the height of the building. Okay. So first is OAD, and then OAE, then ABDE, and then BDC. Okay. So this forms the total area of the figure, which gives the height of the building. Okay. So that means half of OA, half into base into height, half into 20 into 5 for this one OAE. Then ABDE is 20 into 30, and BDC is half into 20 into 8. That means 50 meters plus 600 meters plus 80 meters That means 730 meters will be the height of the building. Now, next, for the next question. Body starts from rest and moves with constant acceleration A. Okay, it starts from rest and moves with constant acceleration A. Now show its instantaneous velocity varies directly at the square root of the distance traveled. Okay, we need to show its instantaneous velocity, which is varying directly as the square root of the distance traveled. Okay, it starts from rest and moves with constant acceleration. So yes. Now see, now for acceleration is constant and it starts from rest. So velocity, initial velocity will be 0. So we need to find out the final velocity. So initial velocity is 0 and acceleration is constant. Okay. So 0 square, that means 0 plus 2as, right? So v square is equal to 2as or v is equal to root over 2as. As the body is moving with constant acceleration, so acceleration is constant, therefore v is directly proportional to root over s. Okay, square root of the distance traveled. Okay, now next question, question number 8. That is, a body has constant acceleration. During its motion, is it possible that a body can travel opposite to the direction of acceleration? Give an example. So for this, yes, the body can travel opposite to its acceleration. Okay, example, when a body is projected upwards with initial velocity, with some initial velocity, it will travel upward direction and its acceleration, that is g, will be in the downward direction. Okay, when you project a body, when you throw a body just upwards with some initial velocity, you throw it. So it will move up, but its acceleration will be downwards. Okay, so that is the example of the body which moves, which travels opposite to its acceleration. This acceleration is acceleration due to gravity. Okay. Next is, why does square of time occurs in a unit of acceleration? Square of time occur in a unit of acceleration. Why does it happen so? It's because as acceleration is equal to change in velocity by time taken. So we know, we have said no, that 4 meters per second square. So why this square happens? This is the reason, as acceleration is equal to change in velocity by time taken. So now change in velocity is change in displacement by time taken. So see, twice there is time taken and both are dividing. So what happens? Change in displacement by time taken square, we can do it. Okay. So that's why it is time taken square. Clear? Next, we move on to the 9th question. An athlete runs around a circular track of circumference 360 meters in 1 by 60 hours and reaches the starting point. Calculate the distance covered by the athlete, the displacement, the average speed, and average velocity. Okay, so athlete, he moves in a circular track of 360 meters in 1 by 60 hours. He moves a 360 meter circular path. Okay, and its time taken is 1 by 60 hours. Now, to reach the starting point, we need to find out the distance covered by the athlete, the displacement, average speed, and average velocity. Okay. So, from the question, we have seen that it's moving on a circular path. So the distance will be the actual length of the path, that is 360 meters. Now displacement, as he reaches to the same path, same point, so there will be no direction, that its direction is continuously changing. So therefore the displacement will be 0. Now average speed is distance by time. So distance is equal to 360 meters and time taken is 1 by 60 hours, that is 60 seconds. Okay, so that means 6 meters per second. But average velocity as displacement by time is the formula. So displacement is 0. Therefore, the average velocity will also be 0. Clear? Next, we move on to the next question. Table shows the velocity of a two-wheeler at a various intervals of time. T is equal to 0, V is equal to 20 meter per second. For T seconds, that is 0 seconds, it moves 20 meter per second. Then for 5, that is initial velocity is 20 meter per second. For next 5 seconds, it moves to again 20. Then next 7 seconds, it moves to 10 meter per second. Then for next 10 seconds, it moves 20 meter per second. Then for 15 seconds, it moves to, its velocity becomes 0. Okay, so two-wheeler, it is the graph. Now, we need to plot the velocity time graph. We need to calculate the rate of change of velocity between 5 to 7 seconds, 7 seconds to 10 seconds, 10 seconds to 15 seconds, total distance traveled by two-wheeler, average velocity of the two-wheeler, and we need to derive this formula. That is v square is equal to u square plus 2a square. Symbols have their usual meaning. So let us move on to the answer of this question. Okay. Let's see. This is the graph, velocity time graph. For 0 second, we have seen from the graph that it is 20 meter per second. Okay. For next 5 seconds, it is again 20 meter per second. Then after 7 seconds, it is how much? 10 seconds. 10 meter per second. Then after 10 seconds, it again becomes 20 meter per second. And then it retards, and around 15 seconds, it comes to rest. So this will be the diagram of the graph of this question. Okay. Next is, what is the rate of change of velocity between 5 to 7 seconds? So from 5 to 7 seconds, the distance covered was 10 to 20 meter per second. The velocity was 10 from 5 to 7. So from 20 to 10. So final velocity is 10 and initial velocity was 20. Okay. So 10 minus 20, final minus initial, by time, that is 2. Okay. So this will be the distance covered, displacement, and this will be the time. So that will be equal to minus 5 meter per second square. Change in velocity, that means acceleration. So we are finding the what? We are finding the acceleration. So first it was initial velocity was 20, then final velocity was 10. So 10 minus 20 by 2, that means minus 5 meter per second square. Then for 7 seconds to 10 seconds, from 7, when it was 7 seconds, it was 10 meter per second, and when 10 seconds it came to, it became, the velocity became again 20 meter per second. Okay. So that means final velocity is 20 meter per second, initial velocity is 10 meter per second. So again here 20 minus 10, and time is 10 and 7. Okay, so starting time is 7 and ending time is 10. So 10 minus 7. Okay, so the velocity by time will be 10 by 3. That means 3.33 meter per second square. Now 10 seconds and 15 seconds. So when it was 15 seconds, the velocity was 0. And when it was 10 seconds, it was 20 meter per second. So 0 minus 20 and 15 minus 10, that's 5 seconds. So that will give us minus 4 meter per second square. The total distance traveled by the two-wheeler. Total distance will be what? Area of ABFO, BCGF, CDG, CDHG, and DHG. Okay. From the figure, see one rectangle, then this is one triangle, this is another trapezium, this is another trapezium. Okay. What will be that? See, first ABFO is a rectangle, so 20 into 5. Then BCGF is a trapezium, so half into sum of the parallel sides into the base. Okay, so into the distance between the two parallel sides. So 20 plus 10 into 2. Again, CDHG will be also half into 10 plus 20 into 3, and DHG will be half into 20 into 5. So that means 100 meters plus 30 plus 45 plus 50. That is 225 meters. Will be the total distance which is traveled by the two-wheeler. Now, what will the average velocity of the two-wheeler? Average velocity will be the distance traveled by time taken. Okay. So 225 meters by 15 seconds, that is 15 meters per second. Okay. Now we know we need to find out this v square is equal to u square plus 2a. So for that, we take v is equal to u plus at. If the both sides we square it up, that is v square is equal to u plus at whole square. So u plus at, that is a plus b whole square formula. So a plus b whole square, that means a square plus 2ab plus b square. So that means what happens? A square, a is u here. So u square plus 2ab, that is a is u and b is at. So 2uat plus a square plus a square into t square. Okay, so b square is equal to u square plus 2u. So sorry, 2a. A is we have taken common, and it becomes ut plus half at square. Ut plus half at square means s. Okay, so that means v square is equal to u square plus 2s. Right. Okay. So this is the end of the chapter, this motion in one dimension chapter. And next video will be some back questions of this chapter. Okay. And what you have told of this, some requests have come from your side or regarding previous year's questions, I will discuss also. I will also discuss them. So before that, I want to finish these chapters which are in your syllabus, and then I will start with the previous year's questions. Okay, so because that will help you in solving all the questions. Part by part, it's very difficult to solve all the questions. So I will first let your chapters finish, and then we will move on to the last year's questions. Okay. Maybe that I will come live to you all so that you can share your questions at that moment also. Okay. So please stay tuned. Please to subscribe my channel. Ring the notification bell so that when new videos upload, you can just get the notification. And if you're liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. Okay. And please to meditate before you start your studies or your day. Okay. So thank you for watching, and have a good day.